Welcome to this channel. In this video, we are going to discuss few problems on BJT, especially the biasing circuit. This video is specially made for our channel members and all you were taking preparation for the GATE exam. So I'll be uploading lots of videos to discuss different kind of problems and the theories. I hope it will help you. If you have any comments, any doubt, please let me know in the comment section. Okay, let us start. The first problem that we will discuss is this one. So here you can see that it is having two transistors. Okay, VB1 it is given base emitter potential, and VEB2 for this transistor 2, both the potentials it is given 0.7 volt, and they are connected one after another. Now the question is, you need to find out the DC voltage VC2 here. Okay, this end is grounded, this potential is 2.5 volt, here one more source, 1 volt source is connected. Okay, now how to find this potential? To find this potential, we need to know the current through this branch, this IC. This is most required thing. But we are assuming that both the transistors are working in active region. Nothing is said, means we are assuming that both are working in active region. Okay, and here you can see that. Now what we can do, this potential we can find out. Okay, this potential I'll call it B. So this is for emitter for the first transistors, BE1 I'll call it. Okay, and this potential I'll call it B base. This is the base potential for the Q2, BB2. Okay, now what is given here, this gap, base emitter gap, is 0.7. Remember, this is plus, this is minus, because base is higher potential and emitter is lower potential for NPN transistor. This is, remember, this is your NPN transistors, right? This is your N, this is your P, and this is your N. Whereas this is your PNP transistors. Don't be confused. Okay, so as it is a NPN transistors, P to N, this gap is 0.7 volt. Similarly here, again P to N, this potential is also 0.7 volt. So this to this gap is again 0.7 volt. Okay, so this thing is given because this is your base emitter for transistor 1, that's your 0.7 volt, and this is your voltage emitter to base for second transistor, emitter to base, because it's PN transistors, its value is also 0.7 volt. So you can see that this potential is 2.5 volt. So what is this one? This gap is 0.7. So obviously BE1 will be this 2.5 minus this 0.7. This is the loss, it's a drop kind of things. Then this potential is available here. So 2.5 minus 0.7 is 1.8 volt. That's simple. And again, as VE1 is 1.8 volt, now what about the VB2? So again, there is a drop of 0.7. So VB2 will be again from this one, VE1 minus 0.7, this drop. Okay, then you will be getting VB2. So it is 1.8 minus 0.7, and that will give you 1.1 volt. So this potential is 1.1 volt. This is your 1 volt because this is the source, this is grounded. Okay, so what is the current to this side? So this is your IB. So I can calculate IB easily. What is the IB? So this potential is VB2 minus this potential is 1 upon the 10K. okay, 10 kilo ohm. So this will give you 1.1 minus 1 by 10, that much milliampere, because it's a kilo ohm range. Okay, so it's 0.1 by 10 milliampere, that means 1 by 100 milliampere. So this much you have got it. Okay, now I need to find out the voltage across this one. Okay, now the beta for these transistors, it is given beta 2 is equal to 50. That we need to use it to find out the collector current. So what is the collector current? Okay, so this collector current, this current is IC. So whether you can write IC2 or I am writing IC only. IC equals to beta into IB, actually beta 2 into IB. So beta 2 is 50 and this is your 1 by 100 milliampere. Okay, so this will give you half milliampere, 0.5 milliampere. Is it okay? So now we are in position to find out the potential drop across this one. So Vc2 is nothing but potential drop across 1 kilo ohm. Okay, so what is Vc2 then? It's simple, I into R. So IC into 1K, 10 to the power 3. Okay, so IC is half milliampere, 10 to the minus 3, and this is your 10 to the power 3. This two will cancel, so it will be half volt, means 0.5 volt. So this is the answer. So Vc2 is 0.5 volt. Okay, I think it is not that much tough. Okay, so you need to understand how to proceed. So if you have more than one transistors, so consider that if nothing is said, consider that all the transistors in active region, and based on this thing you can use IC equal to beta IB. Okay, and VBE is also not given, you can assume that it is 0.7 volt. Okay, fine. We'll go for the next problem. This is our problem number 2. So here the circuit is given, one NPN transistor is given, this is the base side, this is the collector resistance is given 1 kilo ohm. Now it is said that VCE saturation, this one, okay, this to this potential, this is your collector, this is your emitter, so this potential is VCE. When it is saturation, in under saturation condition, its value is becoming 0.2 volt. It's saturated at 0.2 volt. Okay. Now question is that what is the minimum base current so that it will be under saturation region? That's very simple problem. Okay. So as it will be in under saturation region, so this value VCE sat is 0.2, that will assume this end is grounded, so this potential is 0.2 volt. That's simple. Okay, so under saturation, so IC sat will be how much? It is this current, so 3 is the potential here, this potential 0.2, so 3 minus 0.2 by this 1, that is milliampere, because it is 1K. Okay, so how much it is? 2.8 milliampere. Now to get this amount of current, at least minimum, okay, this current is one fixed current, IC sat, you won't get more than that current, but to provide this one, I need certain beta IB, so IB will be IC IB minimum, I can write IC sat by beta, because IC equal to beta into IB. That's simple. So if IB is more than that, then obviously it will be in saturation region, but it may be in deep saturation region. Okay, that will not consider. So this value is 2.8 milliampere and beta is given 50, that much milliampere. So this is 2.8, or I can write it's a 50 into 1000, I can write, and then microampere range, because it could be in microampere range. Okay, So this, it is 200 into 2.8, right? So 15 to 100, it's 220. Okay, so how much it will be? It's 28 into 2, it's a 56 microampere. So answer A is correct one. It's not that much difficult. It appeared in GATE EC 2004. Okay, we'll take one more problem. This is our next problem, problem number 3. Now here again, there's one transistors, but this time it is PNP transistors. It is mentioned that this transistor is PNP. This is your P, this is your N, and this is your P. Okay. Now for this base emitter potential, its mod is given 0.7 volt. It's not particularly mentioned. So base emitter will be minus 0.7, and base emitter to base, that potential will be 0.7. Because this, it is not mentioned, but you should be careful. This current flow indicate that this is higher potential, this is lower potential. Okay. For P to N, this is a drop. This value is 0.7. Be careful. Okay. Is it fine? Now here RB is given 100 kilo ohm. This RB is 100 kilo ohm. And for V0 equals to 5 volt, this V0 should be 5 volt, where this end is grounded. What should be the RC? We need to find out the value for RC so that we will get 5 volt at this output end, V0 equals to 5 volt. Okay. So it's not that much difficult. With respect to this ground, this is a 0 potential. So what is this potential here? This potential is obviously this gap. It's a 10 volt. Okay. This is a 10 volt. Now this gap is there. So what is the potential here? That potential I will call it base potential BB. So 10 minus this 0.7. Again, it's very similar logic. Base potential will be this BEE minus this voltage base emitter base potential. Okay. So this will be your 10. This is your 0.7. So you will be getting 9.3 volt. So this potential is 9.3 volt. So what is the current to this side? This is IB. So IB will be simply this VB by RB. Okay. So this is 9.3 by 100, that much milliampere, because 100 K was given. Be careful. This is K. Right. So we have got IB. Now, what is the potential here in the output side? Because if this is IB, we will be getting one IC current, and that IC current will be this side. Okay. This is your IC. And what is the lesson? We are assuming that it is in active region and IC equals to beta into IB. That's all. Okay. Then what is V0? V0 is nothing but potential drop across RC. This end is grounded. So IC into RC. That's simple. So I can find out the RC value. RC is nothing but V0 by IC. So it is a V0 and IC is beta IB. Okay. If you can replace all the values, you will be getting this exact value for RC. Okay. So what is V0? So V0 is given 5. It is asked for 5. Beta is 50. And IB is this much, 9.3. And this 100 will come here. So that much milli. So this is your kilo ohms. That's all. So 1 0 will cancel. This 5 will cancel. So it is basically 10 by 9.3. 10 by 9.3, it will be around 1 point something 08 or 75, close to that one. It's a little bit more than 1 because it is 9.3, it is 10, very close to 1, but little bit more than that. So this much kilo ohm. Okay, so value for RC is 1.08 kilo ohm. I hope you have got these things. If you have any doubt, please let me know. Write in comment section. I'll be adding lots of videos. Keep watching. If you are a member of this one, you have joined these things, you have not made any mistakes. I'll be adding lots of videos which will help you to take preparation for the GATE exam. And that I'll give you guarantee. Okay, not only this analog electronics, I'll be covering all the subjects one by one. Okay, mostly the problems we'll be discussing. And if you have any doubt on the theory, please let me know. That theory also I'll be discussing. Okay, but mostly the problem session we'll be discussing, and during that time the relevant theory will be also discussed. Please keep watching and make a group. You can invite your friends as well to join this one. Thanks for watching.